So in this part, we're going to actually try and find, or finally, right, find the distance c, the distance between point 1 and point 2, using Pythagoras. So if we wanted to, right, we know we have the following. We have c squared is equal to a squared plus b squared, right? So finding what c squared is pretty simple, right? Like we could just say let's say c, and we can say squared is equal to whatever a is, right, which is that, and b. So in order to do square in coding, you do something like this, or at least in JavaScript. You put 2 asterisks, right? So that is saying a squared. And we're saying a squared plus b squared. And that will give us c squared. But we don't really want, we do, but we don't really want c squared. What we want is c, right? This is a, this is b. This area over here is a squared, this area over here is b squared, but the real utility is in we know a single number that describes this distance. We don't want to know what the area of the rectangle or the square is here, we want to know what c is. How do we find that? For that, we have to do a little bit more just like equations and algebra to do so. So let's have a look, and you'll see how simple it is. So we have c squared is equal to b squared plus a squared, or a squared plus b squared, doesn't matter. Now, the thing we need to make sure we understand is square roots. So when I say a square root of something, if I say the square root of 4, what I'm asking, or what I'm saying is what times what, right? So I'm saying what, like a, let's not use a, let's use x. So x times x is equal to 4. So for what value of x is this equation over here true, right? If I put 3 in here, 3 times 3, I get 9. So this isn't true, right? So x isn't 3. But if I put 2, 2 times 2, I get 4. So the square root of 4 is 2. So that's all that square roots are saying. It's just saying what times what is equal to this number. So what we're saying, if we wanting c, right, we have c squared, and we want c, we could just take the square root of c squared, right? Because, like, if we're looking at, say for example, we took the 2 squared, right? We know 2 squared is equal to 4, but if I just take the square root of 2 squared, right, this is no longer true. If I just take the square root of 2 squared, I get 2. Right? Because we know that 2 squared is equal to 4. Similarly, right? Let's look at another example. If I say 3 squared, I know that's equal to 9. So if I say what's the square root of 9, I know that's 3. So similarly, if I just say the square root of 3 squared, it's the same thing. That's just going to be 3. So whenever we take the square root of something squared, we just cancel out that, right? That squared kind of disappears. So we know if we want to get c squared, we just have to take the square root of c. But we know that in order to do that, what c squared is equal to is b squared plus a squared. So if we take the square root of this side, we have to take the square root of this side. And now what we have is c is equal to the square root of b squared plus a squared. And now what this is saying is for a square, and this is why the area model is so useful, right? Because it allows us, because what a lot of people then do from here is they'll say, okay, that is equal to the square root of b squared plus the square root of a squared, and that is then equal to b plus a. All right, like this happens all the time, but that's just not true. You can't break up this. I wish I had a darker shade of red, but this is a big no-no. Oh, it broke my. So we're back. So this is a big no-no. And we can understand this if we draw the area, right? So what we're saying is, right, we're looking at b squared. We have an area. The area of this rectangle is b squared plus a squared. And now what we're saying when we take the square root is what is the length of this side? When we take the square root, we're asking what is the length of the side, right? To give the analogy, if our area is 9, right, we know that the length of each side is 3. So what is the length of the side? It's the square root. Let's keep it in the same color. I think it's this one. It's a square root of b squared plus a squared. Now that is not the same as the square root of b squared plus the square root of a squared. You have to keep the two together. Simply put, like, you could sub in numbers in order to see this, but understand that when we're taking the square root of a term like this, you can't separate them out. So, and in this case here, this will be equal to c. A lot of math. Let's look at what it looks like in code. So we have what c squared is, right? And all we then need to do to find out what c is very simple. We just say c is equal to, we need the square root function, and the square root function is sqrt. And we just put in c squared. C squared. That is now c. Okay? And now let's put it on the grid, or let's rather print it out first. Console.log c. Okay? And when we do that, go away. Console, we're getting 223 as the value of c. Let's check that, right? So I'll bring up like a calculator here, and we know we have a side 100 squared plus, what's the other side? It's 200 squared. We get 50,000, and if we take the square root of 50,000, which is all of this, we get 223, which is what we get. So perfect, we're getting it right. Okay, so we find what c is. Now the question is, okay, how do we label this? How do we put this position? And now what will be surprising is that it's the exact same as how we found it previously, right? Previously we said, okay, the midpoint of 2 points, if they're just on the same line, is just the average, right? It's just the average of the 2 points. And if it's vertical, if one's on top of the other, it's still just the average of the y points. Now what you'll see is if we have the 2 points on a line or on a curve, and we're trying to find this midpoint in the middle of the two, right, over here, so this is point 1, point 2, and then we're finding this point over here, it's still just going to be the average. And this is where you can see the usefulness of how we've drawn this triangle. If I project this point down, right, I'm going to draw a triangle again. This is my P3. I want to know what this coordinate is over here. I'm looking for this x and y. Okay? Now, we know that if we had this point over here, we know that this point is the same, this y over here is the same as this y. This y is the same as this y. And that's just the midpoint of these two, right? Which is, right, if this is 1 and this is 2, that is just p1y plus p2y over 2. So it doesn't change, right? It's still just the middle of the y ones. And if I want to know what the x is, right, if I go up there, what we'll see is that if we're just looking for here, right, so imagine we're looking between these 2 points, so a point over here and a point over here, we're looking for this point, which is the same x as that. And this over here, this point over here is just the other triangle, that is just going to be p2x. So we know that this coordinate over there is then going to be p1x plus p2x over 2. So it's still the exact same formula, which I find pretty cool. So let's create that. So we're going to say let c label x is equal to p1x plus p2x over 2. And let c label y is equal to p1y plus p2y over 2. And then let's put that in. So we're going to say text, and we're going to say c label x, and c label y. And there it is. You can see the c label, and it's nicely staying in place. We are getting a bunch of these decimal points, which we can deal with. But that shows you this. This was an intense one. So well done in sticking it through, and I will see you for the next part.